much as I did insist on when you have f plus g of something, it is not a multiplication. Still, some people took it as a multiplication. So let me share my screen that should show you on the test. So, for instance, if we for instance, if you take that right here, what is f plus g of 2? This is not a multiplication, right? We agree on that? A lot of people, when I say a lot of people, more than I would like. So consider this as a multiplication. And I remember in class saying that more than once, this is not a multiplication. This is f plus g of 2, right? This means you have to evaluate f at 2, evaluate g at 2, and then do whatever operation we ask you to do. For instance, add them up here in this case, and here subtract them in this case, okay? But in no way this is a multiplication. Same thing here, same thing, f plus g of x. I saw that over and over and over, and this disappointed me a little bit. So because I said this is what find f of 2, right, is find f of 2, which means you plug in 2 in f, which is 2 squared plus 6 times 2 minus 15, right, which is 4 plus 12, which is 1. And you find g of 2, which is negative 4 times 2 plus 1, which is negative 7. And then you add them up. Just do, the answer will be f of 2 plus g of 2, which is 1 plus negative 7. You see, we never said this is a multiplication. We never said that. And here, this is not a multiplication. This is just f of x plus g of x. That's it. But in math, there is no other way to write it down. There is no other way. In some contexts, you understand it is a multiplication. Some other contexts, we understand it's not a multiplication. When you say x plus y, and we say we put here z, okay? This is a multiplication, okay? Because x is a variable, y is a variable, z is a variable. Okay, now then you can do this. You can distribute. But when we talk about functions, we say f plus g of x. The context tells me this is not a multiplication because f is a function. G is a function. This just means evaluate f at x, evaluate g at x. That's it. So this question was also of the easiest questions here. Minus and then plus negative 8x squared minus 15x plus 12. There is no multiplication whatsoever here. We just add them up. All right. So that's one of the few remarks, but like some people, they really did score like some very good grade. I have like 100%, right? Some people have some high grade, etc. So it is less. The test number 2 was better, but it is still better than test number 1. Okay, we're generally talking. So, okay, what we're gonna do today here is we're gonna try to refresh our memories, and from the past test, okay, and we're gonna open up the first test number 1. Remember, the final exam, it is not about being hard. The final exam is not harder than any other exam we did. The final exam is in no way harder than the exams we did. It's all about, the memory stuff. The final exam is just about the memory, okay? So If you do remember the stuff we did, from chapter 1 to now, if you do remember them, then you should have a good final. Okay. Now, if you don't remember them now, it is time to go back and try to remember the topics. Okay, so we're gonna go over, we have a lot of ways to review. You have like the official review, the official final review, which is like about how many problems, I even don't know, like 80 of them. So a lot of problems. So another way to refresh memories is to go over the test we did, right? Because pretty much all the tests, test 1, test 2, test 3, pretty much they cover all the topics, pretty much, right? So we're gonna try to go over them in order to refresh our memories. So what you see here is test number 1. Everybody see that? Okay, that is test number 1. So we did it like back in October, the beginning of October. So we said first factor the GCF, right? So obviously that was the first topic we learned here. And when you look at this, the GCF is what? How much is GCF when you look at this one? So it's
5y squared.
5xy squared, right? Thank you. It's 5xy squared. So now I remember back in the test, I remember some people just wrote the GCF and kept going. No, when you say factor, you actually have to factor, right? You don't have just to write the GCF and just keep going. Okay, if your GCF is very good to write the GCF, but you didn't answer yet until you factor. And when you factor, you have to watch out how my answer should look like. I always put the GCF right here, okay? And then I open my parentheses, and I will always have as many terms as the original. You see here I have 1, 2, 3, I will have 1, 2, 3 in the parentheses. So how I get them now, I divide by the GCF, 5xy squared over 5xy squared over 5xy squared, right? This will give me 4x squared, right? Minus y, right? Plus 3x to the 4th y squared. Okay? So that is the GCF. So on the final exam, if you have to have a GCF problem, it will not be about to trick you. It will be just about to see if you do remember the topic. There will be no tricks in it. It will be just a regular GCF stuff, right? There will be no tricks. Okay, so that is how we used to do the GCF. Now we go to the next one, which is a factor using the negative GCF now, right? You see, we want to see if the students can deal with a negative sign. That's it. But the regular GCF is 3, right? If you do 3 only, then you did not follow the direction. The direction says factor the negative GCF, right? Which means we're going to put minus here. Okay? So just to follow the direction. All right? And when you do that, the thing is, we still do the same stuff. We divide by -2, divide by -2, we get 3x minus 1. And what we see here is every sign did change. The negative sign changed to positive sign. The positive sign changed to negative sign, right? Okay, so that is another, it's still factoring. You see, factoring in Math 083, factoring takes a lot, right? Factoring, the topic of factoring, we use that a lot. Okay, now, factor here by grouping. You see, that is a big hint. When you say factor by grouping, we give you the hint.
Professor,
okay? Yes.
For the last problem, was the GCF a 3 or a -3?
Yeah, it's the same thing.
Oh.
Every time a positive expression is a GCF, the negative also is a GCF. You see, when you can divide, for instance, if a number is divisible by 5, that number is also divisible by -5, right?
Okay.
Okay.
So
So
we could,
here,
yeah,
yeah,
but still divide by -3.
yeah. You see, the GCF, you can put GCF -3, or you put -3 or negative is the same thing. For instance, right here, the GCF, even for this one, even for the number one here, we could ask you to factor the negative GCF. We could say that. We could ask you to factor, instead of 5xy squared, we ask you to factor -5xy squared. Okay?
But
The
then,
truth is, in mathematics, every time you factor by a positive expression, you can factor by the negative expression. It's the same thing.
okay.
I mean, it's the same process.
But I was confused because you had the +3 as the GCF, but then you divided by -3.
Because I factored out -3 right here. Because I put -3 here up front. You see, why I put -3? Because I want to follow the direction.
Right.
If you remove this word from the question, maybe 80% of people will just factor 3.
So
Right?
when it asks you to factor using the negative, it wants you to divide by the negative, or it wants the result, like the answer?
No. It wants you to put the negative up front. Dividing by the negative is a rule. You divide by whatever you put up front. You see right here?
Mhm.
This division right here, why we divide by -3? Because we put -3 up front here, right? Okay, right here, look, why we divide by 5xy squared? Why we divided by 5xy? What is the reason we divided by that? Because we put it out. No, because we put it out. Okay, in general, you divide by something you multiplied by to cancel the effect. You see,
Yeah.
that is just a rule of factoring. You even don't have to factor, in math in general, I mean, this is like fundamental math, as we say. We show you the factoring by the GCF, but in general, in math, you can factor by anything you want, except 0, okay? The rule in math is when you multiply by something, you divide by the same thing to cancel the effect. Just like when you solve equations, when you add something, what you do? You add something on both sides, right?
Mhm.
Same thing, you multiply, you divide to cancel the effect. What I did here is I divided by -3 because I put -3 up front, right? That is a factoring thing, okay? If I put 3 up front, what I do? I would divide by
+3.
by +3 because I put 3 only up front, okay?
But then it would be wrong for that answer. Would
Not
it?
wrong, not wrong, but we don't use the word wrong. You didn't follow the direction. Yeah, I mean, you have to follow the direction. I mean, an answer, you can fail to get the credit because you do not follow the direction.
I see.
Right?
So, I mean, the answer would be wrong, but the work would be right still?
Yes, the answer, I mean, the word wrong is very heavy. The answer will not be following the direction. But mathematically, it is the right answer. It is, it is a good math, okay?
Okay.
You see, it's a good math. So when we say, for instance, when we say this, when we say do this, do multiply, that is a good question, by the way, multiply and simplify, right? Okay, we say 5 over 15 times 2 over 6. Somebody does this, is 10 over 90. And they leave it like that. They give this stuff to the teacher, right? We cannot say this answer is wrong because there is nothing wrong about this answer. But what the answer doesn't do?
Simplify.
Simplify. You see, this answer it did not follow the direction. So as a teacher, if I wanted to see if the student is capable of simplifying, then I wouldn't know if they are capable or not. So I will not give them good credit for this one, right?
Mhm.
Because they did not simplify, but we don't say it's wrong, it's not wrong. Right, so, okay, so right here, the next one here is factor by grouping. I said the grouping is a big hint because they give you the method. They tell you factor by grouping. You see, that's a very good hint, which means we're going to group 2 by 2, right? We're going to group the neighbors. And in O83, We will not give you something where you have to reorder, right? Where you have to reorder in order to factor. That is too much. We just give you examples where if you group the neighbors, it should work, right? So for instance here, we're going to group the neighbors, number 1, number 2, and number 3, number 4, right? What is the GCF here for the 2 first ones? What can we factor out?
2x.
Thank you, 2x. You see right here, because I put 2x up front, I'm going to divide everybody by what? By 2x, right? It's going to be 5x plus 3, no, plus y, I'm sorry. And here's the next one. What can we factor out?
3y.
3y. You see, I see a lot of students doing this and pretty much missing the sign between the expressions, right? This is 5x plus y. And then you don't see no sign here. Okay, when you grade, you're going to be lenient. Okay, you say, okay, you know, it's plus. But please put the sign, right? The sign is very important to put. It's going to be, and then now I have a common factor, which is 5x plus y. It's going to be 5x plus y, parentheses 2x plus 3y. Okay? That is factored by grouping. We did that like 2 months ago, right? Okay, and then we have the easy factoring problems, if you do remember them, something like number 4 here. How to factor the number 4? Because the x square is free, we have just 1 in front of it. We don't need to do the whole steps of, you know, the AC method. We don't need to do that, right? We're just going to be looking for 2 numbers. They're going to, what they should verify those 2 numbers? Tell me.
-7 and 4.
-7 and 4, because they must add up to what?
3.
They must add up to -3, right?
Yeah.
And they must multiply to -28. 28. Everybody agree with that? Do you remember this? Okay, so we're going to put here x here. We put here x here, and then we're going to be looking for those 2. And you just told me those 2 numbers are -7 and +4. It doesn't matter which parentheses come first. Okay? It doesn't matter which parenthesis comes first. It's the same thing. All right. The next one also, we can consider it is the same topic, right? Because in front of x squared, I have 1. Right? I have 1 in the front of x squared. So I can present my answer like this. I put here x here, y here, x here, y here. Now, since I have 1x squared, I can see, okay, in front of each x, I don't have to have numbers. But here I have -40y squared, which means I am expecting to have a number here. I'm expecting to have a number here in front of the y's, right? What are those 2 numbers? They must add up to -3 multiplied to -40. What are they?
-8, +5.
-8, +5. Thank you. It's going to be x minus 8y, x plus 5y. You see that? It's another case of factoring. Okay, now comes this case, which is the AC method. Very probably you're going to see AC method in your final exam, because it's one of the methods we want to know if the student is capable of doing, right? So very likely you're going to see that. So the AC method, I see here shows the steps. You have to show the steps. So what are the steps? What is the main step is how to break down the middle one right here. First, we start to do 3 times -8, right? Which is -24. And then we're going to be looking for 2 numbers that multiply to -24, add up to -2. What are they?
-6, +4.
-6 and +4, thank you. And once I got -6 and +4, what I do, I'm going to break down my middle term using these 2 numbers. It's going to be -6x plus 4x minus 8. Okay? And after that, I'm going to do the grouping thing, right? It's going to be 3x here as a GCF, x minus 2, plus 4 here, x minus 2, which is x minus 2 times 3x plus 4. Okay? If somebody else wrote the 4x first, you see, if somebody else wrote 3x squared plus 4x minus 6x minus 8, this arrangement will be a little bit harder than the other arrangement because of the negative sign which is here. You see? But still, we can do still the grouping thing. It's going to be here x parentheses 3x plus 4. What's going to factor out? The last term, last two terms, what's going to factor out? What is you going to factor out for the last term?
-2.
-2, thank you. Don't factor only 2, factor -2. If you factor only 2, you will not see the same parentheses. But if you factor -2, then you will see the same parentheses, 3x plus 4. It's going to be 3x plus 4, parentheses x minus 2. You see, you get the same answer at the end. All right, you get the same answer at the end. Okay, so again, you know, refreshing memories, again, this is about, you know, what the final exam is about, is refreshing memories, right? So factor 9x squared minus 25. This matches what formula? It does match what formula? A squared minus?
Just there's squares, taking the squares out.
Difference of two squares, right? Remember a squared minus b squared. Somebody tells me how it does factor out. A squared minus b squared factors out as what?
3x
plus 5, 3x minus 5.
Exactly. This is a plus b, a minus b. So I know 9x squared is the square of 3x. 25 is the square of 5. So it's going to be 3x minus 5, 3x plus 5. Yeah, you know, the final exam, what I think from the final exam is each topic, what the final exam will ask you about each topic is pretty much the basic stuff. Why? Because the goal is just to see if the students remember it. That's the goal. You know, we don't take one topic and we ask you something harsh in it, because each topic will be only about one question or two maximum, maybe one question. So if it is one question, that question usually is a balanced question, is a question that is balanced, that is not like hard. I mean, not easy, but not hard also, right? Okay.
How many questions are on the test?
Yeah, for this one, because of the virtual stuff, because you guys have to scan your papers, stuff like that, is only 20 questions for 2 hours. If it was face-to-face, a face-to-face final exam is a 25 questions for 2 hours, because you don't need no scanning, you don't need no pictures, stuff like that. Okay.
Are we be doing our tests at home like we've done all the other ones?
Yeah, in Teams, I will be watching, yeah.
Okay, all right.
Just like we did the test for the test.
Okay.
Okay, so again, the name of the final exam, the title, scares people, final exam, but the content is the same as the test. The only thing, again, I have to insist on that, the only thing is how much do you remember of the past topic? That's the only thing. If you remember the past topics, then the final exam is just a regular test, okay? All right, so x squared minus 2x equal 15. You see here, we say solve by factoring. You remember back then, that was the only method we knew, right? But now we have a lot of methods. Again, I always, I still saw some people, insisting on choosing the method. When we say solve by the square root property, you have to use the square root property. If you just want the grades, If you use another method, I will not even grade it. I will not even see if you are right or wrong. You see here, for instance, solve by factoring. You have to read the direction, please. When you say solve by factoring, you have to solve by factoring. If you solve by another way, I will not even look at it. I will not even see if it's right or wrong. Okay? So I rather do the method and do some mistake on it, maybe get some extra credit, than to do something completely different and get zero. Personally, I would do that. So now, if you want to do solve by factoring, what do we have to have on one side before you factor?
0.
Thank you. We have to have 0 on one side. For instance, here we're going to subtract 15 from both sides. We get x squared minus 2x minus 15 is equal to 0. Now we factor, right? Okay, how we factor this stuff? What are the two numbers?
X plus 3x minus 5.
X plus 3x minus 5, right? So are we done? Do we go to the number 9?
No, we have to subtract each one by 0.
Exactly, you have to set each one, because now we say solve. When we say solve, you are only done when you solve, when you get x equal. You get x minus 5 equals 0, or x plus 3 equals 0. So we add 5, so we get x equal 5, or x equal negative 3. And now we are done. Okay? Now we are done. Okay, so simplify the rational expression. Okay, this is like, kind of going to the chapter 2, if you remember. This is like about rational expressions. Whatever you do in the rational expressions, you have to use the factoring. Pretty much all of the topics, you have to factor. You have to be able to factor, right? So simplify the rational expression. Of course, right here, what we said you cannot do is to do this, right? You cannot do that. All of you know that. You cannot just go ahead and single out a single term and then just cancel out. You cannot do that. So we have to factor, all right? We have to factor. Now for this case here, the numerator is kind of simple to factor. It's x here, x here. The two numbers are?
-4, -3.
-4, -3. And then the denominator, how you factor the denominator? How?
Square of 2. I know it's x minus 3, x plus 3. I don't know
X minus 3, x plus 3, exactly. And then I look at this, I see I have two similar factors at the top, at the bottom. They cancel out. So I get x minus 4 and x plus 3. All right. So that is, you see, again, what you want to students to, what you want to see if the students can simplify, some, a regular expression like that, okay? And this is about factoring. Another one here, simplifying right here, another one, okay? This is also about simplifying here, about factoring and then simplifying. But here, the numerator needs what method to factor? The numerator will need what?
AC method.
The AC method, thank you. The numerator will need, so 10 times -3 is -30. So what are the two numbers? That's going to give me -1. -6 and +5, right? So we get 10x squared minus 6x plus 5x minus 3. So we get here, we do the grouping thing. This is 2x here. It's going to be 5x minus 3 plus 1, 5x minus 3. So we get 5x minus 3 times 2x plus 1. So the numerator here is 5x minus 3 times 2x plus 1. And here's the denominator. What can you factor out from the denominator?
3.
3, thank you. It's 3 times 2x plus 1. Do we have something to cancel out here? The 2x plus 1, right? So my final answer will be 5x minus 3 over 3. And we can rest here. We can rest here. All right, everybody see that? Again, simplifying here. If you look at the work here, is the factoring. So pretty much in the next in the next week or the next 10 days before the final exam, I really advise you to revisit your factoring problems until you know how to do the AC method, difference of two squares, et cetera, GCF, revisit that until you come back to the 2 months ago. Okay.
So
All right.
it's also gonna have the most recent stuff we did, like the log and the.
Yeah, it will have it. So we're gonna go over it. So we're gonna go over it because now we are just the number one. If you don't reach it, then we're gonna reach it next Thursday, right? All right. So this one, which is a division. Every time we have a division, first what we need to do? We need to make it what?
You need to simplify, or like.
Before we simplify, before we even factor, I mean, we can factor at the same time, but it's very important to write it as a multiplication, right?
Mm-hmm.
Remember that it's very important at first to write your division as a multiplication. And when you do so, when you write it as a multiplication, what is you going to do to the next fraction, the denominator, this one, the second one? You flip it over. Thank you. And 10x minus 30. Now you go ahead and you factor if possible, right? So the first numerator, I can factor 5x squared. I see 5x squared parentheses x minus 3. The second one here, denominator, the first denominator I see x plus 1, x plus 5, right? Oh, x plus 4, I'm sorry. This one I see the GCF, which is x times x plus 4. And this one, the GCF is 10x minus 3. Now that I have a multiplication now, I cross out numerator versus denominator. Doesn't matter where they're at, right? You see this x minus 3 crosses out with this one. X plus 4 crosses out with this one, right? You see, I'm not done yet. 5 here and 10 here. I simplify, I have 2 left, right? What I get? X squared times x is x cubed. And here I have 2 left and x plus 1 left. Again, other than writing your division as a multiplication, other than that, all what you did is to factor, right? Remember that? So far, from the beginning of the class up to right now, all the math we did is to factor. That is the math we did. Okay? That is 1 section and a half. Okay? I mean 1 chapter and a half. Okay, so now we have, this one is how to add and simplify fractions. Of course, in order to add fractions, we need to find the least common denominator, right? Okay, and to find the LCD, I need to factor every denominator that needs to be factored, right? For instance, I need to factor this one. This one factored as what? X minus 6, x plus 4. You agree with that? Okay. Since this one factors like x minus 6, x plus 4, what's going to be my LCD?
X minus X plus 4.
Exactly. The LCD will be exactly the big expression that contains everybody. That is LCD. So since the first fraction has LCD already, so I don't need to mess with it, right? But I'm gonna mess with the second fraction. I need to multiply and divide by what?
X minus 6.
X minus 6, thank you. Once I do that, I get a single fraction like this. At the bottom, I have the LCD, and at the top, I have 6x, which didn't change, plus 3 times x minus 6. You see? I added right here. You see, this is the question. You see, this is a perfect example, Natalie, of doing one part of the question right here. Add, we did add. Now, what is the remaining part? Simplify, right? So
Oh, see, I went ahead and multiplied this to 3x minus 18, but I could have canceled those out.
now you see, so we multiply with 3x minus 18, but we don't rush into simplifying again, because when you simplify, you only simplify after you have only factors, after you factor. You see, this x minus 6 here does not simplify with the x minus 6 at the bottom. Them two, they don't cancel out.
Why?
Because they are at the top. The x minus 6 is not a factor. It is just a component. You see, x minus 6 is a component into the sum. You don't see, do you see x minus 6 everywhere? Do you see x minus 6? No, at the first, how many terms we have here?
Oh,
The numerator, how many terms we have?
2.
You have 2 terms. I see x minus 6 in the second term, but do you see x minus 6 in the first term?
No.
Do I see it here?
No.
So you cannot simplify that.
Mm.
You see, when it is addition, when the main operation is addition or subtraction, we be careful with the simplification. For instance, I see x plus 5 divided by 25, right? I am itching to simplify by 5, right? But can I simplify by 5? I cannot, right?
No, because that 5 is with X.
Yeah, because that 5 at the top is not a factor. That 5 at the top is just, is one, is not a factor. It is just one component is addition, okay? I cannot simplify by 5. I cannot do that. I cannot single out the 5 and then cross out. That is like, but that is a very common mistake in math, okay? A lot of students do that. So this is what I can do here. The maximum I can do is 3x minus 18. And then I group the like terms. 6x plus 3 is 9x minus 18 over x plus x minus 6, x plus 4. Now, if I can stop right here because there is no simplification going on, no further simplification. But
you wouldn't
factor the 9. Yeah, that's a good thing. You could do that. Unfortunately, it doesn't lead to no more simplification. When you do that, it does not lead to any simplification. You see? Yeah, it does not. You can factor out the 9 because it's very nice to factor out the 9, but unfortunately, it does not lead to any more simplifications, right? Okay, but in this topic right here, how to add, what you guys remember, you have to remember the LCD, right? You have to remember that. The least common denominator and how to write every fraction with the least common denominator, right? So, and I think, is that it? No, it's not it. Okay, I think we have this one right here. Okay, so by now we have seen this problem like I don't know how many times, maybe like 100 times, right? This type of application problems. You see, it was even in the test number 3. We said we launched an object that's gonna go upward, and then that is a free fall stuff, right? Come back, and we say is a height in feet The height is given by negative 16t squared plus 48t. That is a height after t seconds, right? Back in test number 1, when we did this test like 2 months ago, the question we asked was, after how long the object will hit the ground? That was the question we asked back then, right? In test number 3, did we ask the same questions? Do you remember in test number 3 what question we asked last week?
Maximum height.
Exactly. We asked about the maximum. That is about the vertex. That was about the vertex. But here, 2 months ago, we didn't know what was a vertex. So we didn't ask that question. We asked the question, after how long the object will hit the ground? And what we said back then, we said, at the ground, how much is the height?
0.
The height is 0, right? If the height is 0 at the ground, so my variable h in the equation, I will set the equation h to 0. It's going to be 0 equal to negative 16t squared plus 48t. And then I will solve that, right? And the method we know back then, again, the only method we knew back then was GCF, factoring. So we're going to factor this by negative 16t, parentheses, we have negative 16t, it's going to be t, negative 16t minus 3, right? Equals 0. And then we're going to set each factor to 0. We got negative 16t equals 0, or t minus 3 equals 0. So the first equation, when you say negative 16t equals 0, how much is going to be t?
0.
0, exactly. Don't say 16. It's not 16, it's 0. Because when you divide by negative 16, 0 divided by any number is 0, right? And then here you add 3, you get t equal 3. You see, I have all what look like 2 solutions, but really, what is a solution really? If we take into account the context, what is the solution?
It's the vertex.
No, here I have 2 values of t. I have t equals 0 seconds and t equals
3.
3 seconds, right? You see, after how long here, we anticipate some time, right? So that's going to be my final solution. This 0 right here would correspond to the fact the object was launched from the ground, you see. If the object is launched from the ground, the height is 0 before the launch, right? This is where the 0 comes from, okay? All right, so this is like one word question. You can have the same one, maybe not, right, you know. But the word questions we saw in this classroom, we have this type of word question. When we, word problems, when we launch something, we have the sharing the job, etc. You know, not much, we have variation, not much word problems, not many. Okay, now comes this one, the proportions. Do you remember what we do here? If you have one fraction equal to another fraction, how we start to solve this problem? How?
You need to get a common denominator.
Do we really need to that in this case?
No.
my course is leading, right?
Yes, thank you.
But do you remember when you have one fraction equal to another fraction, how we call the process? What can we do? It has a name. The process has a name. We said we simply do what? We simply do. I know if I do the arrows, everybody's going to tell me the name. We do this and this. How we call it? We cross.
Multiply the reciprocal.
Multiply.
You cross multiply. When you have a fraction equal to another fraction, you cross multiply. Now, do you see now why the final exam sometimes people find it hard? Do you see now? That is a very good proof of that. I remember back then when we did this topic, everybody, particularly this problem, everybody did it, particularly this one. But now if people are hesitating, is the memory is fading a little bit, right? So that is why you need to go back and review that, because you never know if you have this, if you will have something like that on the final exam. For this one, you cross multiply, you get 6 times 7 minus 5x equal to 9 times 4 plus 2x, as simple as that. And then we just solve, we distribute, you get 42 minus 30x equal to 36 plus 18x, right? Okay, and then we group the x's on one side. For instance, why not add 30x here, add 30x here? Why not? And then subtract 36, subtract 36. So we get 6 equal to 48x. We divide by 48, divide by 48, so we get x equal to 6 over 48, which we can reduce by 6, 1 over 8, right? We called it cross multiplying back then, okay? So now this is test number 1. This was test number 1, right? This did cover chapter 1 and the big deal of chapter 2, okay? That was test number 1. Now, when we go to test number 2, so let me share it. Okay, this test number 2 start also with chapter 2, and it start with a rational. It does start with a rational equation that we said back then. We said the easiest way to do the rational equations, the easiest way. You always, in math, you always have a lot of ways to do something. But the easiest way in this case is to multiply each term by the LCD at the top. Not top bottom, only the top. Multiply each term by the LCD. But first we need to find the LCD, right? And to find the LCD first, we need to factor everyone that needs, every denominator that needs to be factored, right? Okay, this one need to be factored. And remember we said this one is likely to be what? Before we even factor it, is likely to be what? Can you tell me is likely to be?
Whatever the other two is.
Is likely to be the combination of the other ones, right? But we need to check it out. We don't just assume, okay? But the big denominator is likely to be a combination of the small ones, because if it is not, then the question is harder, right? If it is not, then the question is way harder than if it is. So we double check that. We don't rush, we double check that. So effectively, this one is actually x minus 2, x plus 5, right? Now, what is the LCD now? Of the three of them, the LCD of the three denominators is actually L, x minus 2, x plus 5, right? And what we said again, the easiest way to do this stuff, the easiest way is to multiply each equation above. You see, I do x minus 2, x plus 5, x minus 2, x plus 5, x minus 2, x plus 5, right? And then I go simplify here. X minus 2, x minus 2 cancel out. What I have left? 13 times x plus 5 minus x plus 5 cancel out. 6x minus 2. And here everybody cancels out, equals 17. Every time you do that, every time you multiply by the least common denominator and you simplify, you will have a very simple equation as a result of that. Okay, now what you're left to do is to distribute. You get 13x plus 65 minus 6x plus 12 equals 17. We group like terms, we get 7x plus 77 equals 17. Subtract 77, you get 7x is equal to negative 60, and then divide by 7, we get x equal negative 60 over 7, right? So tell me, somebody tells me, before I say this is definitely my final answer, I have to compare this number with what numbers? What numbers cannot be solution? Because of the denominators, what numbers cannot be solutions anyway?
2 and negative 5.
Thank you very much. 2 and negative, because those two numbers, they make the denominators be 0, right? And in math, we cannot have a a 0 denominator, right? Okay, so before you box your answer, take a second to compare your answer with whatever number makes the denominator 0, right? Okay, everybody. So, but again, in this process, what do you remember? We remember to multiply each term by the LCD. That's what we're going to remember. Multiply each term by LCD and simplify. Okay. All right. So now comes this one right here. John can complete a job in 9 hours. Rebecca only 4 hours. How long will it take them to complete the job if they work together? You can set up an equation and solve it. Okay, so do you remember what equation we set up for sharing the job? Do you remember the equation, somebody?
We make it a fraction, so like 1/9 plus 1/4
equal what? 1 over x, saying that x is
1 over x. Okay.
x is the time they need. Okay, if you do remember the equation, it becomes a very, very, very easy problem. If you don't remember the equation, it is a hard problem. There's no middle ground. It's either a very easy problem if you remember this equation, or a very hard problem if you don't remember it, right? And now you see, this is my equation, and now I just go ahead and solve it. What is LCD? 36x, right? I multiply by 36x, multiply by 36x, multiply by 36x. I go ahead and simplify. We get here 4x plus 9x equal 36. We get 13x equal 36. So we get x equal 36 over 13 hours, right? Okay. So that, again, in case you can have this stuff on the exam, please remember the equation, okay? Okay, the next one, again, some type of application problem. Y varies directly as x. And remember what we said, what equation this is going to give me? When I see y varies directly as x, what equation I write? Y equal what? Somebody remembers y equal?
Is it k divided by x?
No, k times x.
Oh.
When we say y varies inversely, when we use the word inversely, then it's going to be y equal k divided by x, right? When we say y varies directly, is k times x. Y varies inversely is k divided by x. You see, I have my equation is y equal kx. Now, the first stuff right here is allows me to find k. I put here 3 here for x. I put here 19 for y. I got 19 equal 3k. So k equal to 19 divided by 3. Okay? Which is about 6.3. All right? So now, what I do, find y when x is 17. So I have y equal to 6.3 times x. So now if x is 17. So y is going to be 6.3 times 17. That's it. So again, you know, we just want the students to remember what means varies directly, what means varies inversely, etc. This is what we want. All right. Okay. Now we enter the chapter 3, where we have to simplify the radical expressions. Okay. So do you remember, to simplify this, we need to 32, we need to break it down into what numbers? We need to break down 32 what numbers, using what numbers?
You need to pull out the squares.
One of them has to be a perfect square, the other one maybe not, right? So what are
Right.
the two numbers we're going to choose in for 32?
Wait, oh, whoops, I was looking at the other one. 16 and 2.
16 and 2. Thank you. The 16 is a perfect square, so it is eligible to go out, right? Because it's a perfect square. But once the 16 goes out, it becomes one number. When it gets out of the square root, it becomes what number?
4.
4. But the 2, is the 2 eligible to go out? The 2 is
No.
not. Yes, you see. X to the 15th, we're going to view it as, we're going to break it down as what? X to the 14th times X, right? Okay. The 14th is even, so it is eligible to, we can, X to the 14th is a perfect square, so we can get it out. But what square root does to even exponents? Do you remember?
Divides it by 2.
Thank you very much. A square root divides even exponents by 2. So it's going to be X to what power then?
The 7.
7, right? The other one is not eligible to go out, it stays inside. The y to the 8, the 8 is even. So the whole y to the 8 can be out, right? But it becomes y to the what power? 4th, right? Square root divides your even exponents by 2. Square root divides your even exponent by 2. What cube root does, on the other hand? What cube root does? It divides them by what? Cube root
What?
divides your exponent by what?
By 3.
Cube 3.
By 3, right? Cube root divides your exponent by 3. Here we kind of lucky here, because when you look at the two exponents inside, they are divisible by 3, right? There is no remainder. It is harder when we have a remainder, right? But on the test, on the final exam, I will not bother with that, right? It will be X to what power? 15 divided by 3 is 5.
6.
And y 6 divided by 3 is 2. That's it. Okay. So the next one is kind of the same thing. We need, you see here, I don't have like radicals yet. I don't have like radicals, so maybe I need to see how can I simplify the numbers inside to get like radicals. 18 breaks down at what numbers? 9 and 2. The 9 goes out, become what? Once the 9 goes out, become what?
3.
3. That'll be 7 times 3, square root of 2. Minus 10, square root of 2. And the 50 is 25 and 2. The 25 goes out, it becomes 5, is 5 root of 2. This is 21. 21 root 2 minus 10 root 2 plus 5 root 2. So since I have a like radical, I just put square root of 2 here. 21 minus 10 is 11 plus 5 is 16, right? 16 root 2. Okay. So here, for this one, I need to FOIL. Okay, the first arrow, 5 times 3 is 15, right? Minus 5 times root 7 is 5 root 7. Plus 2 root 7 times 3 is 6 root 7, right? And then comes the last one, minus 2 root 7 times root 7. These two right here combined, they become what? When you combine, they become just 7, right? They be free of. When you multiply 2 square root together, you can remove the square root, right? And 2 times, it's going to be 2 times 7, which is 14. It's 15 minus 14, which is 1. And these two together, negative 5 plus 6 is positive 1 root 7, right?
Would it be the same if you didn't have the 1 outside and it was just square root of 7?
It's the same thing. I
Is
just
it-
put the 1 in front just to make it, you know, to make it like obvious.
I couldn't remember.
Yeah, exactly. So, and this one right here, the next one is kind of the same thing, you see. So these two together is 9. And then the 2, you see, the 9 comes from 3 times 3 is 9, right? And then root 7 times root 7 is just 7, 9 times 7. Plus, this right here is 15, coming from 3 times 5, root 7, minus 15, root 7, right? These two cancel out, and then minus 25. So we get 63 minus 25, which is 38, right? Okay, do you remember rationalizing the denominator? For this type of problem, you have to simply multiply, divide by what?
You multiply the numerator and the denominator by the square root.
Exactly, thank you. So this becomes 10 root 3 over 3. That's it. This one here needs more memory for this one. Actually, we need to multiply, divide by what?
The conjugate.
Thank you. The conjugate of the denominator. Who is what? What is the conjugate of the denominator?
Plus 5. Square root of 29 plus 5.
Exactly. The minus changed to plus. When you do that, the numerator will be this. We don't need to distribute, you can leave it like that. But the denominator, remember, we said if you have 2 square root, it's going to be 29 minus 25, right? Because it's going to be, this is a minus b, h plus b. It's going to be root of 29 squared minus 5 squared, right? And root of 29 squared, they cancel out, going to be 29 minus 25. That's it. For you, you need to remember this step right here, multiplying by the conjugate of the denominator. That's what you need to remember. So for this one right here, remember, sooner or later, we will have to square both sides, right? Do we do it now? What you need to do before we square both sides?
You have to move the 3 to the other side.
It's going to be square of 2x minus 19 is equal to 7. And then now we square both sides. We put square here. We put square here. This will kind of cancel out. We get 2x minus 19 is equal to 49, right? We add 19, add 19. So we get 2x is equal to 68. We divide by 2, so we say x equal to 34. Now, what we need to do, after we're done calculating, what we need to do to avoid having a fake solution, we need to check the answer. Remember that? Now, if you don't check the answer, and that is still a good answer, it's good for you. But sometimes you can have a fake solution. To avoid that, we check the answer here. If I put 34 here, I got 2 times 34 is 68, minus 19 is 49, right? The square of 49 is 7, 7 plus 3 is 10, okay? So this is what it works. Do you see those two steps? To the maximum, you're going to have that on the final exam. To the maximum, 2 steps only. Okay. All right. And here, the complex numbers. So of course, we're going to FOIL. Normally, we say 2 times 3 is 6. 2 times 5i is 10i. Negative 7i times 3 is negative 21i. And now comes the last one, which is negative 35i squared. Do you remember what we said? This will become how much? Do you remember?
Positive 35.
Exactly, because I squared is negative 1, right? I squared is negative 1. That's why this becomes positive 35. We get 6 plus 35 is 41 minus 11i. So this is like chapter 2. Okay, so pretty much when it comes Thursday, for anyone who wants to review, okay, so if you come Thursday, we're going to do chapter 3 right here that we just tested on. So now, of course, you know, the logarithm and stuff like that, we cannot just figure them out just like that, okay? So, because they kind of new material stuff, okay? So right here, but for these 2 equations, the only equation we saw is the exponential equations. The only type of equation are these right here. We don't mess with the hardest ones. But this here, you see the 27 is not like, it's not here like accidentally. We can't solve this because the 27 is an exact exponent of 3, right? If you put any other number, then it's going to be way harder. So 27 happens to be 3 to what power? 27 happens to be 3 to what power? 3 to the 3rd. Now, every time we have the same base raised to 2 different exponents, what we must have? The 2 exponents must be what?
Equal.
Must be equal, right? They have to, because you have the same base. We have base 3, base 3. So 8x minus 5 must be equal to 3. And we just solve for x. This is not really hard, you know. As a general topic, exponential equations can be very hard, but not in OAD3, because we haven't reached that level of math yet. See? Okay? We haven't reached the level of math where the exponential equation can be hard. We haven't reached that yet. So, and here we solve for x. We add 5, so we get 8x equal 8. So we divide, so we get x equal 1. For this one right here, about the same thing. We're going to try to write 25 to the 3rd in the base 5, right? But 25 happens to be what? 5 squared, right? That is 25. So when you say 5 squared and then you raise it to the 3rd power, this becomes 5 to the 6th power, right? You have to multiply the 2 exponents. Now that you have base 5, you're going to say this exponent must be equal to this exponent right here. So we get 9x plus 3 must be equal to 6. So we subtract 3, we get 9x equal to 3. And then we divide by 9. So we get x equal 1/3. All right. These 2 now, this is write the log form. The log form, we have to figure out 3 topics, 3 numbers right here, and right here, right? So the easy one to figure out is the base. What is the base here? Look at this expression. How much is the base?
9.
The base is 9. No ambiguity. The base is 9 right here. Now, between the 2, between the 729 and 3, which one we're going to put in which case? We have to remember, we said the outcome for the log is always the exponent. This number right here is always exponent. It's the 3 right here. And then this is going to be 729, right? That was it for the test number 3. For this one right here, what is the exponential? The exponential here, we have to put the base raised to some exponent equal to this. Again, what is the base here? Do you have any doubt what is the base here?
3.
The base is 3, right? Now, okay, now we are hesitating what to put here and what to put here. You remember, what is the outcome for the log? We said.
Where did you get the 3? Because it says log 3.
Log base 3, yes, it says log base 3. That is base 3. See, this is log 3 here. This reads what? Log base 3, right? Okay, so between the two cases, right, what to put here, we remember that the outcome for the log, the output of the log, the value of the log is always the exponent, right? Where am I going to put the -4 then? Where? On the right side or as an exponent?
Exponent.
Exponent, right? So the -4 is the exponent right here. And
I
here,
mean, basically, I can if I just remember how to do it, that's great. But I don't understand what this means.
yeah, no,
It would
pretty
really
much.
be a matter of just memorization without understanding what I'm doing.
No. It's like this. It's like this. We're not digging into the log concept, the whole log concept. What we say is this. This is a definition of log. What you write here is a definition. Now, a definition always starts with the memorization, because this is a very definition of the log, right? For instance, we say log is an operation in math. We said that another way to write a to the x equal y. What is the definition of log? Is to say log base a of y is equal to x. Okay? We don't understand a definition. We know the definition. Now, if you go to further classes other than 083, if you go to further classes, calculus, then you will deal with the log where you need to understand some operation with the log. But for now here, we need to know the definition. You see the thing? I think in the test, you didn't know the definition. And that is the problem, you see? But
It was a problem.
yeah, because we have to know the definition. You see, everything in math, a lot of stuff starts with the definition. Now, when you do a lot of calculations on the topic now that we didn't do in 083, then we need to understand some other stuff about the thing. But first, we need to know what is the definition of log. For instance, 3 weeks ago, we never talked about log, right? 3 weeks ago, there was no log in our vocabulary. So now suddenly we say, okay, there is some functions in math that we call log. What is the definition of log? Is another way to write an exponential expression. It's like you never heard about square root, right? Okay, and we say, okay, there is another way to write 3 squared is 9 by saying squares of 9 is 3, right? At first we learn what this means. At first we memorize this stuff of writing, this way of writing. So I can mimic those. I say 7 squared is 49, so I mimic the same stuff. I say squares of 49 is 7, right? That is the first thing. So
yeah,
and then
I don't know what my problem is with logs.
yeah, so the log.
Against logs.
Yeah, so this is the thing. So if we would do, if it was another class, then we will have to do some problems with log. Okay, then we need to dig a little bit deeper. What is log exactly? But here in 083, it's like the beginning of log. We just stay on the definition. What is the definition of log?
Sorry.
So the definition is how to rewrite an exponent. You see? So we say 6 squared is 36, right? What is the other way to write the same expression using log? That is where we at, not further. What is the other way to write the same expression using log? What you say? Mimicking the definition. You say log. What is the base?
6.
Base 6 of what? We said the outcome for the log is always the exponent.
2.
Is equal to, see, this is where we at with log. Now, if you're gonna do like, you know, some more math, Well, I don't know if this is your last math class, but if you do 163, you're gonna learn a little bit about log. If you do 165, you're gonna do more. You're gonna learn more. If you do calculus, definitely you're gonna learn more. You see.
Can
But
I?
for now, for the final exam now, everybody in this class has to know how to go from one form to another. How to go from one form to another. You see. Yes.
I just do a swirl, like a swirly. Like
Yeah. Yes, you do.
I go from like how the 6 is, I take an arrow and I take it to the 36 and then I loop around to the 2 and that's how I remember how they are.
Exactly, and exactly, and this is exactly, you see, for instance, I say this exponent this equal to this, right? 6 raised to the second power equal 36.
Right.
And Noel, your question is a good question. It's only in O83 we don't learn how to manipulate log any further. We don't learn in O83 how to manipulate log, the log function any further. We don't. If you do more math, then you will use more logs, and then you're going to be more familiar what is log exactly. But for now, it is learning what is the definition of log. As a definition is a definition. You see, the definition is a definition. For instance, we say, okay, this is log, and then we have to try to be familiar with the definition. For instance, we say, this is my expression 9 raised to the 10 power. Since this is a very big number, I don't know, I say A. What is the log form of this? Log base what? What is the base here, clearly?
9.
Base 9, right?
A.
And then I have to fill up these two squares. So we say the exponent is always the one that is by itself. And it's going to be A, you see? And that's what we need to learn for this topic. All right. When you come back Thursday, I think we have only the test 3 left to, you know, that if you had a good, we have only the test 3 left to review. If you have a good, if you don't feel like, you know, coming to review the test 3, you don't have to come. You see, it's just a review for the with the test 3. If you have some questions, you can prepare them for Thursday, you know, so we can try to answer to them. Again, you know, definitely the final exam in the O83 has an impact. Why? Because of the proportion is 30%. So I would encourage everybody to prepare for the final exam, not to panic. I'm not saying panic, no, it's not a regular exam, okay. The final exam, just a regular test. The only thing about it, I repeat again and again, the only thing about it is cover something we did 2 months ago, right? That's the only thing about it. But you will not see a question on the final exam that is harder than the one we did in the test, I promise you. So it's just about a memory thing, that's it. So, so prepare for it because it has an impact on the grade because of the proportion. But at the same time, do not panic over it because if you did good so far, there is no reason not to do good if you take your time and review, all right? Okay, see you Thursday, everybody.
Okay, thank you.
Thank
Bye. Thank you.
Bye, thanks.